Welcome everyone to Learning with Rev. Today we are going to be learning how the MNIST data is formatted when you load it into Keras. For those who don't know, MNIST stands for the Modified National Institute of Standards and Technology. In their numbers database or dataset is one of the most common datasets used for introduction to machine learning and deep learning. It is built into Keras as a Keras dataset, and you can load it using the MNIST.loadData method. Normally when you do it, you format it like this: xtrain, ytrain, xtest, ytest, but why do you do that? And in this video, I'll show you guys why. We are using Google Colab, and this is a Jupyter notebook. You go to my previous video if you want and check out why I'm using Google Colab and why it's so useful. This info function is just a little helper function I'm using. It's going to return to us the type of the data and either the shape of it, the size of it, the length of it, or the value of it if it is not iterable. So let's do MNIST load data and then run the info on X. So X is a tuple and it has a length of 2. So let's do X and Y. So that means each part of that tuple should one part of it goes to X, the other goes to Y. Inside of there we have 2 more tuples, and there 2 and 2 again. So this is how we get to X train, Y train, X test, Y test. We're going to load this data, and now we see we have a NumPy array. Dimension with the shape 60,000 by 28 by 28. Y train is just 60,000, Y test or X test is 10,000 by 28 by 28, and Y test is 10,000. We know from the documentation at this link right here that we should have 60,000 examples of images in the training data and 10,000 examples in the test data, which is how we know we have given the right names to our variables here. This means we can iterate through the first dimension of these NumPy arrays to access each image and label. So in this function here, we are looping just through the first 3 items in xtrain. So we're going to grab the first item in it, grab the info on it, grab the first info on the first Y value in train, which will be the label. Then we are going to name this image, name this label, CV2 IM show image, and print label. This function here is a helper function that Google Colab has actually created here because the standard CV2 IM show breaks in Jupyter notebooks. It's been known for a very long time, but they have this nice patch for it. The images are going to look kind of small because they are 28 by 28, but that's okay. We should be able to see it, and I can zoom in if it seems too small. So we're going to loop through here. We get our outputs. So first we get our info on our first image. It is a NumPy array with shape 28 by 28. Next, we get our info on ytrain, so this is the label. It's also a NumPy array, or it's actually a NumPy unsigned integer, my bad, not an array, and its value is 5. Next, we show our image, and I can zoom in right here, and that is definitely a 5. And the label we're printing out is a 5. So perfect. Then we repeat it again. For the 0 is the next one, and then 4 is the third one. So now we can see what these images are, what the data really is, and how it's shaped. But we have to do some things before we feed it through a neural network. First thing we have to do is we have to scale our images between 0 and 1. While it's not 100% necessary, it's much easier for these neural networks to learn when their input data is normalized between 0 and 1. We know that these are saved as like a standard image file, scaled between 0 and 255. So black is 0 and bright white is 255 for each pixel. So we're going to set our xtrain and our xtest data, convert it to a float, divide by 255. Now we are going to change the shape of our images. Xtrain We're going to expand dimensions across the last dimension. So this is what the -1 is. It takes where the last dimension is and expands it once. And then also, we are going to take our Y data, our labels, and use this Keras utils toCategorical function and one hot encode it using, we're going to give it, say it has 10 possible values. One hot encoding is when you take a value like 4 here and we change it into an array, and I'll show you what that looks like in just a couple seconds. Right here, we're essentially doing the same thing again. What we just did in the above function, we added a little bit more. We multiplied the image by 255 and then saw what the label looks like in a little more detail. So, our shape for this image now is 28 by 28 by 1. So the image 28 by 28, vertical, horizontal, we need 1 because our neural network is expecting each image that gets passed through to have color channels. These are just black and white, so we can essentially dump the color channel when I was first showing it to you, and when the data is stored, saves a significant amount of data. But Keras and TensorFlow will be expecting the color channel. If this was a color image, this would be 28 by 28 by 3, where 3 is your RGB if you're using something like Pillow, or BGR if you're using OpenCV to open your images. Once again, we could see that our value here is 5. Get NumPy array, type 10 and 0 now. So this is the one hot encoding for the number 5. We told it it's going to be 10 long, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's going to be, we're going to start counting at 0 for this value here. So 0, 1, 2, 3, 4, 5. It's called one hot encoding because all the rest of these are zeros, and we have a 1 in the position that represents 5. We could do this again with 0 here. It is in the 0th position, and 4 will be in the 0, 1, 2, 3, 4th position. If you want here, you can look at that code. If anyone wants to see this code after the fact, let me know in the comments and I will post it somewhere so everyone can see it. Now we want to see how this data is passed into a neural network. We're making a 1-layer network here, or actually 2 layers, really simple, just so we get a rough understanding. From the Keras API, the fit function takes an X, which is your data, Y, which is your labels, and batch size. So Keras is actually looking for a 4-dimensional array. We have 3 dimensions here, 28 by 28 by 1, but it wants it batched. So standard batching 16 or 32. So really this array will be, let's say 32, 28 by 28 by 1. That's just how TensorFlow and Keras expect it to be. So we are building a sequential model, the most simple model in Keras. In my next video, I'll be showing you all how to make that. Take our input. We're expecting each individual to be 28 by 28 by 1. We're going to flatten it. So now it's going to be sized, if you take 28 by 28 multiply together, I believe you get 756. I'll put in the annotation if that was incorrect. And then we have a dense layer here with 10 outputs, activation of softmax. We compile it with a loss of categorical cross entropy, basic optimizer atom. We're going to look at the metric of accuracy. We're going to grab the model.summary and then plot our model. Like I said, in the next video, we'll really go into depth what compiling and what these layers are. 784 is the shape. I think that's what I said before. It flattens it to that shape, and then it outputs 10. We have our input layer of 28 by 28 by 1, flattens it to 784, and then we output 10. So if I uncomment that now, we can see it is training. And honestly, for a one-layer network, pretty good accuracy or pretty good validation accuracy. So that was a quick introduction to how the MNIST dataset is formatted and how you can understand it. Thank you all for watching. If you have any questions, please leave them in the comments. If you like this video, please like it and share it. Hope you all learned something, and I'll see you next time.